Give it a moment. Stream.
Uh, I totally hate checking the stream now because there's always commercials.
I
Like
know.
this is the third commercial now.
Lame. You have to watch 3 commercials?
Yeah, I'm
Oh
not the
boy.
one streaming, so I can't actually. This is like a terrible interface.
Oh boy. Lame.
It used to be it would go straight to the stream and I could just be like, "Yay, validating, everything looks good."
Yeah. All right. Well, I got it on the phone. It's sounding good. Yeah.
Yeah, it sounds good. You
Okay.
sound good. I'm now off commercials.
Sweet. Okay. Well, let's go.
We still need a little song and dance to go with
We should.
that.
Yeah, we should. Damn. Well, for now, what status? Oh, okay. Here. We were looking for this last time. In progress. Is that the one? Oh yeah, bookstore. That's right. We lost all the code for this when I
So we'll have to
intelligently.
start over.
Yeah. Hey, Asen Kov, thanks so much for the follow. Good to have you.
So if you haven't been here before, welcome to us doing some collaborative learning of Go. Aaron has kindly um, volunteered
And Jennifer has
to
kindly volunteered her algorithm and data structure skills to me.
so that we can one Aaron will get to think back about what it's like to be a learner in Go, and I get to level up my Go skills.
Win
And
win.
we've been going through the exorcism tool to the Go track specifically. um, what was the difference between like the moderated
Hmm.
versus not? If you do decide to do this, like what did we end up? We switched our track, right?
Yeah, mentored. You can't move on till they answer
Yeah.
you. And
Yeah, and that can take
practice.
a while.
Yeah.
There was like one suggestion once where it was like it'd been a week and we're like, okay.
Dude, we're trying to move on here. Yeah. Yeah, we're in practice mode. Oh, check it out. We didn't, maybe we didn't mark this as done or something. What else is there? There's unlocked. That's ev. Oh,
Everything.
is it? Because when I go to all, it's a million things.
Oh.
So there's all.
Oh, why is acronym locked for you?
Oh, wait. Where was that? I,
Oh wait, no, it's not locked. I'm like, oh, it's just really tiny. Maybe because unlocked includes wait, are those bottom ones locked?
no, it's all open lock.
Hmm. Maybe it's completed versus uncompleted.
Oh, man, maybe. So there's 109 in all. And we have two unlocked is 23, so it's 25 plus 8 is 33. Oh,
Oh,
they're locked,
wait.
but they're unlocked. You know what? I
Huh.
wonder if this is like, hey, if you were in mentored mode, these would be locked.
Well, they would like most of them would be. Oh,
That's a
that's
good
true.
point.
Like,
I don't know. Yeah, that's a good point. That totally disproves my theory. Well, I don't know.
okay, do we want to go back to the book one and start the
Yeah.
bookstore one and just start over?
Yeah.
Do
Fuck.
you remember like the logic here?
I remember that you knew the logic here. That's all I got for you.
I can't remember whether we went with a spreadsheet or a what did we do? We did a
Oh.
spreadsheet or
Buckets. Something
yeah,
about
I was
buckets.
like the buckets.
Yeah.
The buckets.
Okay. Oh, this. Oh man, I deleted all the code. Okay, actually, wait, before we go on, I'm gonna put this in GitHub.
That sounds good. So we don't lose it again.
Yeah. Oh, Elixir. Interesting. Okay. Uh, this probably has nothing in it, huh? Oh, it does. Okay, let me just for right now, new repository. Exorcism, go.
So if you want to follow along, you can find this in the Go track, and if you're in practice mode, you can just open it up. Otherwise, if you're in the moderated one where they provide you feedback, you can't so much get there. I can't directly link to it because it just will. The link is to. It's a link to my solution, which I haven't submitted a solution, so it's not going to work. But the gist of this is that we are trying to encourage more sales of different books from a popular 5-book series. The bookshop has decided to offer discounts on multiple book purchase. If you buy one copy of any of the 5 books, it costs $8. So that's like if you buy a single book, $8. If you buy 2 books, different books, you get 5% discount on those 2 books. If you buy 3 different books, you get a 10% discount. 4 different books, 20% discount. And if you buy each of the 5 different ones, you get a 25% discount. If you buy 4 books, of which 3 are different titles, you get a 10% discount on the 3 that form part of a set, but the 4th book still costs $8. So this is where we were thinking about like buckets, and so like how you like how someone chooses to buy different books. So if you buy 2 copies of the first book, 2 copies of the second book, 2 copies of the third book, 1 copy of the 4th book, and 1 copy of the 5th book, then you can think about the buckets of purchases. And so there's 5 unique, and then a bucket of 5 unique, and then a bucket of 3 unique. And so there's 2 different discounts, 25% discount for the 5 and 10% discount for the 3. And so then it's just like a normal little calculator.
And this thing wants us to get
up
the biggest discount, right?
No, it give the total price with the biggest discount.
The total price. Okay. And then they want
So
us
it's
to
like,
write a cost function. Okay. Well, let's write a cost function. And then that thing is going to be testcase.basket, which is going to be a slice of integers. And I'm assuming cost needs to be, yeah, it needs to return an int. Okay. Basket. Slice of integers, and we return an int. Okay, we're done. Return
nice.
5, 6. We're done. Okay.
Oh, so the total cost is
It's always 6. That's the best bookstore if you're looking to buy in bulk.
yeah, $6 for all 5 books or 100 books.
You know what? I remember here. We were maybe it was just me. I was confused if the slice, if the index in the basket is the book number, or if it's something else. I remember we had 2 ways to describe
We
this.
went back and forth between a map and a slice, back to a map. And then we looked at the test cases, I believe, so that we could see how they share it. And so like, yeah, so this was, remember this, it's 1 book of 1, and this is 2. This is like 2 of 2. This is like, they should have just done a 1 and a 1 because it makes it very confusing. So it's not like 2 of 2. It's like there's a book 2 and a book 2.
Oh, yeah.
Yeah.
So then, yeah, we changed it into a map where we had the key was the book number, and then the value was the number of that book, right?
I don't know that we did that. I think we were just doing. Mm, yeah, I don't remember.
Okay. So you, let's see if we can remember your algorithm. So by three and
So the danger of doing exorcism is it's like its own little thing in case you've never done this. And it's doing its own little you submit to it. And
mm-hmm.
early on I was like, we should share this on GitHub. And it was like, oh no, but then you have two Git repositories. But yeah, we lost all our work because we got halfway through. And if you've ever been on one of our previous streams, you know that Aaron loves to install new operating systems. Wait, which
Mm-hmm.
operating system are you on right now?
I am on Pop OS, and this is I will. I think I have 2 weeks to go, and then this will be the OS. No, I have a month to go actually, and then I'll this will be the OS I've run the longest on the tower, longer than Windows even.
Oh wow. Okay, so Pop. I'm gonna go down the tangent here.
It's I'll put the
So
link in there.
is this
Oh yeah,
system 76 Pop OS? It's like Pop. Like you got to
pop.
add like a little pop
Yeah,
because there's an exclamation point.
pop OS. It's a
Oh,
cool.
oh yeah, this is right. The auto tiling with Pop Shell
Yeah,
and the workspaces.
yeah.
This sounds pretty cool.
It's really nice. If you have a PC, this is the closest Linux I've seen, closest to Mac.
Aaron is driving Linux on the desktop
It's the
by
year
himself.
of Linux. They have this company's look at they have. I mean, this tower is beautiful. Oh, come on, show me the case. Yeah, look at that.
Wow.
They're taking a similar kind of like Apple model where they're trying to sell hardware, give away the OS for free, and really concentrate on like making the OS and their software just work and be really slick with
And you can
their
have
hardware.
cool oh like that blue.
Mm-hmm.
Click on the blue that's like, "Oh, I'll take
That's
one of
that's
those."
trippy. There's
Oh,
blue.
now
What
if
is
I could
this?
get like instead of like the wood grain, if I could get like space and like
Yeah,
stars, like that would be so awesome.
yeah. Hey, Fallen Back, what's up? I know you didn't say hi to me, but what's up? It's good to see you.
Oh, hey, Phil.
So this one is
Phil is awesome peeps.
you have to be in a robe sitting in a smoking room. That's this one. This is the trippy one. It looks pretty cool. This is the trendy one. I don't
I
know.
don't know about the that one. That one's like to match your IKEA bookshelves.
Yeah. This one just looks unfinished to
That's why I
me.
said IKEA
Yeah. Oh yeah,
bookshelves.
yeah, yeah. I
The
see what you're
Billy
saying.
bookshelves that are like the beach color.
Yeah. And then boom, this one. Plain. Not plain. Standard.
So do you have one of these?
No, no.
Okay.
This is like Mac Pro prices. Like,
Okay.
let's see here if I can build one. Well,
I'm just
you
gonna
can
say
start.
it. I can't believe we've already gotten distracted. Okay,
No.
you know what? Maybe we should choose a different problem
Okay.
instead of the bookstore one
Okay.
because I feel like the bookstore one is not fun times for us.
It was tough. Do you want to
It's
do a
tough, but we
medium?
figured it out. It worked. We
I
just
know.
didn't submit it.
And now we're all demotivated. At least I am.
Okay, let's do an easy one and get some good feels.
Okay. I like it.
Okay, protein translation. I think this one sounds great.
Protein translation. Okay. This is gonna be one of those easy, hard ones or something. All right.
Well, no, because like this is like a biology one, but like you translate uh the way that it translates is that, like one maps to another.
Mm.
Like it's real. It should be straightforward. Although this might be a little different than what I thought it would be.
See, RNA can be broken into three nucleotide sequences called codons and translated to a polypeptide. So AUG blah 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 translates to AUG, triple U, and then UCU. So groups of three, I guess. Yeah, three nucleotide sequences. There are 64 codons, which in turn correspond to 20 amino acids. All the codon sequences and resulting amino acids are not important. If it works for one codon, the program should work for all of them. Feel free to expand the list in the test suite to include them all. There are 3 terminating codons called stop codons. If any of these are encountered by the ribosome, all translation ends and the protein is terminated. All subsequent codons are ignored like this. The stop codon is UAA. Okay.
So it's assembly code for cells.
Yeah.
It's great. This is not what I was thinking it was going to be. It's not even like how it translates. It's just like how to read it. So this is cool.
So what do they
So it's
want us
basically
to do?
it's taking like, so you're going to get like a string that is a bunch of AUGCs, and then you're taking each 3 slice. So like AUG is methionine. UUU or UUC is phenylalanine. I totally am probably saying these wrong. And then there's leucine, tyrosine, cysteine, and tryptophan.
Nice.
And then stop.
Tryptophan's coming up in Thanksgiving. Anyway,
this is very relevant.
Yeah.
So we're basically, where's the actual question?
That's yeah. I'm not sure.
Okay,
nice.
we gotta
Falling
look
back.
at the code.
Wife is taking intro to programming class for bio people. They're doing exactly this, but in Python. Nice. I'm sure it's nowhere near as advanced as this. We're dealing with what, 7 proteins and a stop codon. This is
No. This is like when you see what we have to do. Well, let's look at the like test.
Okay.
They don't actually tell you what to do here, though. They don't say
Yeah.
like what are they expecting.
Maybe that's part of the.
So like it's literally taking like 3, like you get a string and it's like, okay, here's this, and then like tell me what this is.
Oh.
And then like edge cases of if it's invalid codons, like that's not valid, right?
Okay.
So the only valid ones, and this is what happens in biology, right? Like if like a mistake happens and something gets flipped, it's a way to detect it. So
okay.
yeah.
So I see, like,
Is it really only like in 3? Are these the cases?
Oh, there's some details.
What is the other?
Oh, that's benchmarks. This is it. And then you're supposed to return air stop if
it's an invalid.
Yeah.
So like
an air invalid. So we definitely have to create these errors.
Well, it's like we need to define what is valid inputs, and that like valid 3 letter slices, 3 character slices, and then anything that's not valid just goes away. So like
so
there's literally the codons. Yeah. Wait.
Invalid.
Is that an actual error? Wait, go back.
It's expecting the this expected error. So
but stop isn't an error. That just means you stop. That's like the end.
Yeah.
I guess it's if. I would say it's an error if you get a stop and then there's more stuff after it, right?
I don't know what they expect. I mean, they want us to represent a stop codon as an error. Even though
but do they, or do they mean it's an error if you parse, because you can totally parse a stop, but there's more after it? I don't know. Like,
I don't know
do you
either,
see what I'm
because look,
saying?
check it out. If you do from codon UGA, you're supposed to get empty actual back and an error back. And the error they expect is air stop.
Oh, okay.
So,
Interesting.
yeah. She's they're making her implement all these solutions with recursion. Huh. That's interesting. You could build a map with recursion and it'd be the slowest map ever. But you could do it. So okay, I guess we need to make a map then, huh?
Yeah.
From from codon. And then we basically need a map, right?
Yeah.
Hey, Lockham and King Coop. Thank you both for the follow. Welcome, welcome. Good to have you. Okay, so we need a map, I guess. Codons equals map. String to string. And then we're just going to copy that thing, this thing. Oops. That.
Awesome. What's the special key characters to like auto do your little quotes around something?
Oh, so on a PC it would be shift control and then like the cursor's over here, so left. And once you have it
Oh.
highlighted like that, if you just do like shift quote, VS Code will know it's highlighted, so I'm gonna put quotes around it. Right?
Oh, yes.
Right?
Oh, I love this. Oh my goodness. On a Mac it's just shift like just highlight it and then shift
Yeah.
quote. So like that's beautiful.
I mean,
That
control left and right just goes left and right word by word. That if that helps. Hey, Doc Mustard, thank you too for the follow. Welcome, welcome. The map is
But
from
why
each
is it
codon to the
in
corresponding protein. That's falling back. That's at least what we're thinking. Maybe you know something better
but
here.
why is it an error? Why are they saying like your program should return an error if you get a
Yeah,
stop?
good question. Oh, and secondary metabolites. Wonderful name for this exercise. I assume metabolites is
Exactly.
something related to proteins. Proteins stop at the stop codon. That's why it's called the stop codon. Yeah, I guess. I mean, I guess we can represent it as the error, even though, like, I don't know. Seems like that's not an error. It's just like you can stop now. It's time to stop.
Yeah, it's just
So,
like stop.
yeah.
Like
But that's how they want it in the code. That's the abstraction. So that's the abstraction, I guess.
64 codons, which in turn respond to 20 amino acids.
Computational biologist? Cool. Yeah. Well, um, I guess maybe you can tell us if we're doing this right, because I'm pretty sure they just want us to call from they want to call from codon and give us a is it codon? Yeah, they want to give us a codon and have us return the protein name, or if they give us a stop codon, they want us to give them an error called error stop.
Oh, you know what? So we're not even getting RNA in. They're just giving us a codon.
Yeah, they said they don't. What they say? Blah, 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 blah. There are 64 codons, which in turn result in 20 correspond to 20 amino acids. However, all the codon sequences and resulting amino acids are not important in this exercise. If it works for one codon, the program should work for all of them. Feel free to expand the list in the test suite to include them all. So I think they're just saying if we can give you one codon and you can give us back one protein, then it should be fine for all of them. Oh, and Fallenbeck says the input is an RNA string, and then metabolites. So you get the RNA broken up into these triplet groups. Okay. So something else is going to break them up into triplets, right? And then those are going to get fed into us.
Are we supposed to break it up into the three?
Stellar question. I
Like
mean,
that's what the test looks like. It's not. It looks like here's the.
we could add more. We are
Oh
supposed to.
wait, wait,
Okay.
wait, wait. But you know what? Here we go. Below is the protein test cases, and it's See, I thought, yeah.
Oh,
So this is it. So this is what I was. This is what I was thinking we were going to be doing. Is
okay.
you get the string, and then you're like doing the slice and saying, "Here's this."
Yeah. So there's another function here from RNA that needs to return a slice of strings and take
Yeah, so
in
we're gonna slice
a
every
string.
three, and we're gonna say
Yeah.
what is the protein, and we get if we get something back that says this is a stop, then we're done, and that like that
Hmm.
we stop. And if we get something that is
Like this here. This is supposed to be just tryptophan. So is AGA a stop? Let's see
no,
if this.
AGA is invalid. That's why
Oh,
it's
invalid.
the invalid
Oh,
base.
duh.
Yeah,
Okay, yeah.
they should have an example where it's stop.
Is there one here? One, two, three, four. Yeah, this one's a stop,
AG.
right? UAA. So there's only two here. But maybe we could add one like this with a valid thing after the stop and then make sure that it only
So
returns
this is
two.
basically like all of these should if it doesn't have a stop, that's a problem, right?
Yeah. Wait.
Is that a problem?
Apparently not. Because look. Metabolites are falling back. Do you know if something just straight up ends and doesn't have a stop? For any real bio application, you just stop when hitting stop and ignore the rest. Okay. Okay, we can do that. But is it an
But what
error?
happens if it doesn't have an explicit stop?
Exactly, yeah. Because like this right here. If it doesn't have a stop, that's weird.
Error, error. Invalid RNA.
It's like if we don't have stops, aren't we just gonna keep growing? It's an error. Yeah, they don't think it's an error.
So based on this, like the examples in the protein test cases, it seems like stop is just a way to the error stop is a way to signal that it's complete,
Yeah.
and you don't have to parse anymore.
And I think the idea is
Um,
they want us to build this. This from RNA is kind of the main attraction. And they want us to build that on top of the other one up here. And this one returns that error. And that kind of makes sense because then we're going to be doing our loop for every three in here. And then we can see, we can detect, oh, is this a stop? We can check for an error to see if it's a stop. Outside the computer, you'd hit a stop eventually. For a bioinformatics app, you just keep going as long as you have strings. If people pass you an invalid RNA string, it's on them. Okay.
cool.
Okay. All right, so let's build the easy one, the small one first. Because that one's just a map, pretty much.
Cool.
So I just have to do the old data entry thing here. All right, so serine. Put these on new lines here.
Okay, so I'm just gonna talk about this biology piece some more while
Yeah.
you're doing data entry. Okay, so secondary metabolites. So we have each of these things are proteins, and then so which thing is the amino acid? Is it the chain of proteins? each of the proteins are amino acids. Oh, wait. So which thing is the amino acid? Because like there are 64 codons, which in turn correspond to 20 amino acids. Oh, is AUG? That's the amino acid. Right. So that's what that like yeah, so that's why I was thinking it meant. Right. AUG is a codon. And AUG is, it says protein is methionine. I think that's where I'm like I'm tripping on is I'm like, wait a minute, okay. So, yep, that creates proteins from RNA. Ah, okay. So if this little machine gets the code AUG, then this machine spits out methionine. Not that AUG means. Got it. Got it. Okay. So we're actually not creating, we're creating a little cellular generator that's taking RNA sequences and the expected proteins that we're supposed to build out. Cool.
Gotcha. Okay.
That makes so much more sense. Thank you.
So the values in this map, those are amino acids, no? Or what are they called? Proteins. Okay. Okay. So we're going to say protein OK equals codons string. So do you remember this notation, Jennifer? The OK thing?
I don't. It's been a while. Before you answer that, you did get a question about what extension are you closing curly brackets?
I love this extension. So, okay. Whew! This extension is called coding biscuits. So if you go to VS Code, biscuits, and it is called assorted biscuits. So assorted biscuits is for a bunch of different languages, including like HTML, CSS, but also programming languages. They'll show you where this curly started. And it's super useful if you've got like, if it goes off the screen like that. So that,
oh, nice.
So that's that. But also on the technical side, this extension biscuits is written in TypeScript, like many extensions in VS Code. But there are a bunch of parsers under the hood that break down, in this case, the Go code into an abstract syntax tree, and then the TypeScript walks up the abstract syntax tree until it finds the beginning. Those are all provided as WebAssembly modules. So behind the scenes, there's these lightweight WebAssembly modules parsing the Go code, and then the TypeScript calls into it to get the AST, and then it does its thing. Finally, this person, CM Griffin G, he is the author of Biscuits, and he builds this plugin on his stream. So you can see it.
Oh, that's nice.
Yeah, that's how I found out about it. So that's my, thank you for coming to my TED Talk. I love this extension, especially with HTML. Because, you know, if you have a huge, like a div or something, or a body tag, and there's a bunch of HTML in there, obviously it'll tell you where the body tag started, but it'll also tell you if you messed something up and forgot to close a div or something like that in between. So yeah, enjoy. You're welcome, Lockham. All right, so back to this. All right, so this notation is get me the value of this input in the map. So, it's like a map, a dictionary in any language. If you give it like UUG, it'll give back leucine. And that value will be in this protein variable. But protein will return as an empty string if the value is not in this map. So that sucks because then you can't reliably check if it wasn't there, because what if we had this? You wouldn't know if you got ABC passed into the function or you got something that's just not in the map at all.
Okay.
And that's what the OK is for. So this is a built-in to Go. OK will return true if stir was found in the map and protein is an actual value, or false if it wasn't in the map. And in that case, protein will always be an empty string. So what we're going to do is, if it's not OK, then we're going to return empty string and error invalid. And then otherwise, we're going to see, since we've got to return the stop, then in that case, we've got to return that stop error. We got to do that. And then otherwise, return protein and nil. So
Cool.
I think this one was easy. So I think
Mm-hmm.
let's take
It's
a
really
walk on the
straightforward.
wild side and not run the tests yet. Cool with you?
No, no, let's go ahead and do it.
All right.
Let's see.
So let me implement this function so that we can actually compile the thing from RNA, and this is going to be stir, and then we're going to return a string slice and an error. Return nil nil. So all those tests are going to fail, and that's fine. So we can go here and run this. Cannot use stop codon as string. Oh, duh. Okay, sorry. We have to make these errors a little bit differently. So you can't do like ABC whatever here because this is a string and it needs to be an error. But the way that you would make an error would be that. Whoops. And I don't think you can do that, but let's see. I'm pretty sure you cannot do this, but we're going to see.
Do you need to import errors? Is that what it's telling you to do?
It automatically.
Oh, it did it.
Yeah.
Oh, that's right.
Yeah.
It will automatically do that goodness for you. Okay.
Yeah. So yeah, I guess it worked. I didn't think you could do that, but apparently you can. So test codon is a working test. All right. So that's from codon. Let's collapse it. And we need to do from RNA. So we definitely need to break the string into 3 elements of, or groups of 3 characters at a time. So let's see how to do that. See what goodness they have in here. If we can like break it up every X characters or something.
Looks like at least one of them is the wrong number of characters.
Ah, okay. Well, we can handle that. Are we supposed to return an error for that?
No, it's going to be like the protein and then, well, in this case, it's an invalid base. So it's like we return as much and then we just error out as soon as it fails.
Okay. Hey, metabolites, what do you do if you get like a string that's not a multiple of three characters? Like if you get like ABC or UGG UU. So it's like you
The
okay,
body
you'd return
said.
her. Okay.
Oh no, but what does the body do? What does the little body computer do?
Yeah, what does the body do? Is that like time to go to the hospital thing or
No. This is like when you get like some funky do cell or something.
yeah. I guess is that cancer?
No, no, I would think it's like what is it? Phenylalanine.
Oh, wouldn't do anything.
Lalanine.
Okay.
Uh, well, isn't this a regular problem? Like if something get like if the wrong protein doesn't like what is the thing? I have a soda right here. I'm like, what is the thing in it? It's like phenylalanurics or whatever.
Phenylketonurics.
Phenylketonurics.
Yeah.
Yeah.
Like they can't metabolize it.
Yeah,
Um,
yeah, like I don't know. Maybe that's
you
not the same thing.
you need three bases to get the amino acid inserted. Okay. It'll only ever happen at the end, right? So we can check then. We can say if length of string mod 3 not equal to 0, return error invalid base, I guess.
But wouldn't that cover it does it's not in there?
Right. So it'll.
Like if you slice it and it's not a valid string? I mean,
Oh
I don't know,
yeah,
maybe
you're right. Yeah. Because then the like metabolite said, it's gonna happen. The last one is gonna be like one or two, and we'll pass it into from codon, and then it'll be invalid.
hmm.
If in a biology context the last character in the RNA was missing, you'd lose one amino acid. Okay. Well, that wraps up nicely in a little bow. So basically, we've got to take our. Oops. We have to figure out how to get a slice of three strings from each. Three string subsets is what I'm
Hmm.
trying to say. I'm probably trying to even say that terribly, but doesn't look like this has anything to do that for us. So, oh wait, split n slices s into substrings separated by sep and returns a slice of substrings between those separators. Oh, we don't really have a separator then, huh?
Is there a way to slice with three characters? So
Um,
like based on index or something?
no, but Asankov has a great point. You can use recursion. You just build up a list from cons. Proteins usually are hundreds of amino
We're
acids
back to
inside.
recursion.
Yeah. One more or less at the end doesn't really matter. Okay. Yeah, let's use recursion then. So, basically, we need to get the first three, figure out what codon that is, or what protein that is, and then append the rest of it to to that. So, current codon equals string 0 to 0 to 3 because 3 will not be included, and then protein equals from codon, current codon. Asankov, good call, because this would have been painful otherwise. I think we would have had to write a loop with two counters and blah blah blah. From codon, okay. So if error not nil, if the error actually is stop, then in that case, what do? We just we return cur codon, right? No.
No, if it's stop, then we're done. It's like we're done.
So right, we return an empty string array and no error. So that the caller of this just appends nothing to it.
Mm-hmm.
Okay. And then else if error is something else, return nothing and that actual error. And then after we deal with the errors, then we want to return. Oh, and the rest remaining
So it looks
proteins.
like it. Can we take a peek at the test cases again for
Mm-hmm.
this one? Because it looks like, would it be that we would return whatever string we've already built up, or
Exactly. Yeah.
okay?
Well, we will return whatever slice.
Well, go down a little bit more. That last one.
Yeah.
See how
so,
it returns this string? So that
Mhm.
first one is tryptophan, and then it's but it also returns the error.
Oh, you're right. So I think this is still right. Oh no,
Would
you're
it be
right.
like you're going through all the whole string, and like you're going through the whole sequence, and you're adding to your string, and then as soon as you discover this error, you either, if you run into an error, if it's stop, you stop and you return the string. Otherwise, you stop and you return the string and you return the error.
Yeah. So I think basically you're right. If we get any error, we just return nothing because this is either a stop or invalid. So we return nothing and we return the error as well. Oh, we return the error if it's not a stop. But if it is a stop, same deal. We return nothing, but that's not really an error. It's just we're done. Metabolites, can't you just loop over the input string steps of 3 and append the amino acid to an array? Probably doesn't matter for the test cases, but if your RNA string is tens of thousands of characters, worried about stuff. Yeah, that's a good point. But doing the loop would be too easy.
Well, I was thinking we could just append it to a string, right? Just a string. Like you go through the loop. This is what I was thinking you would do, is like in the steps of 3, and
Yeah.
like just add it to the string. And then when you get that error, it's like, or you get to the end, you just return the string. You're done.
No, but that would be too easy. We have to do recursion. We don't have to do recursion. Let's do the recursion
Whatever
way.
works.
Let's
Yeah.
do the recursion way and the loop way.
Okay.
Is that cool?
Yeah. It's fine.
Okay. All right,
As
so we've
long as
got the
we
current
don't
one and the
delete our code.
Oh, what? I'm sorry. What? I totally interrupted you. What did you say?
I was joking. I was joking. As long as we don't delete our code before we submit it.
I will check it in. I'll check it in early and often. Okay, so we've got remaining. This is where we're gonna do the recursion from RNA, and then the remaining is gonna be stir 3 and onward. So this is string slicing. This is saying get me the characters from 0 to 3, but not including index 3. This is saying get me the string starting at index 3 to the end. And then this,
Cool.
if error is equal to error stop, then this needs to return the same deal, empty string and nil, I think. Else, if error is not equal to nil, meaning it's something else, return a string empty and the error itself. But then finally, we want to return this as the first element of our final array and then this is the rest of it. So we can do append. So what this is saying is, oh, and we have to do nil here. So what this append is saying is, this should be this is the beginning of the slice. So we have a slice of one string. We want to append everything in the remaining protein slice onto the end of this slice. So in theory, this will work. Oh, actually, this needs to be protein.
I want to see it running, and then I'll be able to understand.
Okay.
I'm like, wait a minute, something seems a little off.
I'm sure this will break, but let's see.
No, it'll run perfectly.
Uh-huh. Slice out of bounds. Oh, is there one that has nothing in it? No, there's not.
There's one that doesn't have 3.
Okay.
Well, like it's like 3, 3, 3, 2. So this, like, I guess with this style, if the length is not, like, you do need to calculate the length.
Yeah. What do we do?
We say it's invalid, an invalid base.
Okay. And by the way, if you have any slice at all, you need to return an empty one of it. Whether this is slice string, slice of int, slice of whatever, slice of my custom struct, you can always do nil. And that's actually a little bit, it doesn't really matter so much here because we're not really looking for efficiency. But nil is generally more efficient because it signals to the Go runtime that you're not trying to create any memory. You're just saying it's nil. So if you're writing a server that's got a lot of traffic going to it and all that, this could probably will make a pretty big difference over time. So let's try to run this now. This is for expected methionine, phenylalanine, and tryptophan. Is that the first? Oh. Okay, this one passed. That's good.
So why did this one fail?
Got error invalid.
You said it was invalid. So this sounds like it didn't get the first one. So what do we have for, wait. Why did we, because like, look, AUG.
Yeah, AUG.
We should have at least gotten methionine. Like, we should have gotten the first two for sure.
Yeah.
Can we step through it?
Yeah. Let's do a let's go down here, and I want to do like a watch point here. Conditional breakpoint. We want to do it when we got this. We want to do test.input equals that. Okay. It worked. That was weird. Okay. Test.input AUG.
You sound surprised that it worked.
It said like you have to create a thing, and then it didn't make, and then it just said, okay. It let us off the hook. Like we didn't have to create a thing anymore. So that's cool, I guess. All right, so we've got our AUG, UUU, UGG. AUG, UUU, okay. So we're going to step in now. Okay. AUG, UUU, UGG. The length is bigger than 3. Current codon is AUG from codon. That gives us methionine and no error. Error is nil. Mm-hmm. Now the remaining proteins is an error. Okay, so we've got to run this again and step into the recursion.
Wait, so what's the last one?
Um,
So it didn't find the phenol whatever.
I guess
Uh,
so.
So we've got some logic here is an issue, but can we go to the top of the map?
Hmm.
And which one is this test case? It's saying it's UUU.
Yeah. And then
So
UGG.
why is this one failing this time? Because like actually this test case is the same as the first one. It just changes the last
You know what I think we should
protein.
do? I think we need to run the test again and then step in to here, step into each
Okay.
recursion and see what happens when we get to the final thing.
Okay.
Oh, I think I know what it is. I think
Uh
it's right. Oh, what do you got?
no, yeah, keep going. I'm like,
Okay.
what? I'm like, I don't see it. I don't see it yet.
Okay, let's do this. Let's do this again. We'll step in. We know this stuff is fine. It's AUG, the protein is methionine, no errors. And now we're going to step in. This is the first recursion. So now we've got the
The-
rest of the string after the AUG.
And the length is 10.
Mm-hmm.
So it's not stopping there. Okay.
Ker codon is UUU. The protein is phenylalanine.
Oh, so it does find that one.
Yep. I think it's going to be the very end. So, like, we're saying if the length is less than 3, but what if it's 0? So,
Wait, then why did the first one pass?
because the length there was not less than 3.
Oh, because there was stuff left over.
Mm-hmm.
I got it. Got it. I totally get it now. So in the first test case, there was a stop before and there was stuff afterwards, and
Mm-hmm.
that was fine. We handle the stop case,
Yep.
which is great. We don't handle the there's nothing left in the string case.
Mm-hmm. So let's prove it though. So tryptophan, that's fine. And now let's check out our call stack here.
I totally see it because it's like we don't handle an empty string.
Yeah. So then we go into here, empty string, boom. So let's handle it down here before we call from RNA.
Because it's basically we're saying, okay, RNA is done.
Yeah.
We're done.
Rest of string equals stir 3 and onward. If rest of string equals empty, then return, return,
The string, yeah.
and then that's going to have protein inside of it. And that's it.
Yeah.
So let's see. We're going for the gold. Expected tryptophan, UGG, AGA, blah, blah, blah. So it would be
That's
this
that
one.
last one.
Okay.
Yeah, where it's an invalid base. Is the second one is an invalid base. So
Okay.
we're not actually returning that first protein. This is the thing where it's like we got to return the string.
Okay. Okay. I don't I don't get that yet, so I'm gonna go through and debug it and see what
Oh
happens.
yeah, no, that's fine.
Debug, okay. Test dot input is that long one. Okay. Step in. We're fine on the string. The codon is UGG. From codon is going to give us tryptophan. The rest of the string is AGA, blah, blah, blah. It's not empty. So now we're going to step in. Now the string is the remainder. Codon is AGA. So that's a stop. Is that a stop codon?
No, no, that's an invalid.
Invalid. Okay. All
Yeah.
right. So we've got our invalid. Okay. It's invalid. It's not a stop, but it is nil. So in this case, were you saying that we have to return something instead of nil?
No. Keep going. So what we're doing is we're not returning that tryptophan from the previous one.
Oh,
Like we're in. We need to end when we get to invalid. So we need to return that tryptophan and whatever else, like in any other case, whatever else is in the string that's already been figured out,
okay.
and the error.
So we're back up here. We stepped up the recursion, and if we get an error from RNA, that was with the AGA, that should give us back, yeah, that gave us back invalid. So so it's right here where we have to return tryptophan.
Yeah. So this is where I was like seeing yeah.
Okay.
Well, wait a minute.
I think you're right.
Okay.
Because we're saying we're trying to get the rest of it, but the rest of it's invalid. So we need to just bail. But we need to preserve what we already have that is valid.
Okay. Then why aren't we doing the same way with stop?
For stop, they don't want us to include the stop codon. So we're saying
Right.
we're done, and we've got nothing right now because we're not supposed to include the stop codon.
Okay.
But up here, this is for this codon. So obviously, if it's a stop, don't include it. But if it's an invalid codon, don't include it either.
Okay. Well, let's see if it works.
Yeah,
I
let's see if
feel
it
like
works.
there's something not quite right. But it worked. Woo.
Ooh, we got some
Okay.
followers. Wisdom Matt and Foo for the City. Thanks for that follow, both of you. Thank you so much. Thanks for being here. Okay, so all right, we got the recursion way. Should we do the loop way?
We do not have enough time today to
Oh,
do the
that's right.
loop way.
Okay.
So we should go ahead and submit this, even though it's not the loop way, but we
Okay.
should pick this up next week.
Yes. Well, let me check it
And
in.
refactor. Yeah.
Actually, let's go here. Oh, it's already committed. Okay. So we're not going to lose it now, even if I install a new OS. And we're going to
Or you have a
submit.
hardware crash.
Yeah, or I have a hardware crash. Gotta live on the edge. And then we're going to submit protein translation.go. I'm going to put in here one more thing. Oh, we need to, okay. Let's put in some to-dos actually.
Oh, that'd be helpful for next week.
Comment the public symbols, vars, functions, etc. Implement from RNA iteratively. Let's make that a little clearer. As a loop, not recursively. Hey, we did this on a Twitch stream, and one of the people watching was a computational biologist. Booyah. Metabolites, that's for you. That's for you right there. Okay.
That's awesome.
We're going to submit. I will, let me open this up. Booyah. And a to-do list. Okay. I'm not going to mark it completed. Maybe next time also we can view community solutions too.
Awesome.
Okay, so if anyone wants to check stuff out, we have all the code up here. I just checked it all in. Me and Jennifer will be back on. Are we doing Wednesday, Jennifer?
I don't think Wednesday works this week,
Okay. Me and
but I
Jennifer
will be back next week.
Monday, same time, right?
Yeah.
12? Okay. Yeah, same time. Noon Pacific time next Monday. Fallen back. Thank you so much for that follow. You are amazing.
Fallen back. I have never, in all the years, I have never thought of pronouncing it that way. That's great. Thank you.
What's the way that you pronounce it?
Oh, it's just Phil.
Oh, it's just Phil.
Like Phil.
Okay.
It's like Hollenbach.
Hollenbach. P. Hollenbach. No, I like Fallenbach. Phil, you are now Fallenbach forever.
Congratulations on your nuptials.
Oh, congrats. Fallenbach. Congratulations.
In this time of awesomeness, we need lots of things to celebrate. So, yay.
So, yes, me and Jennifer back on Monday, noon Pacific time, doing more of this. We have a lot to go. We have like 100 of these exercises to go, I think. A little over 100. We're going to do them all,
And
right?
or if someone comes along and like it's like, hey, how about we do this thing? We can try new things.
Yeah.
We're always open to learning the ins and outs of Go. I mean,
Yeah.
that's what we're all about.
Yeah, it was a lot to learn. So yeah, we've got that coming on Monday. I'm gonna be on at least twice more this week doing Kubernetes stuff with Kata, and that might involve some Rust. Definitely involve some Go. Might involve some Rust. I don't know.
Woo-hoo!
You're gonna have to tune in to find out. All right, y'all. Thank you so much for coming. I will see you later this week, hopefully, and we will hopefully see you on Monday, a week from today. Thank you so much for coming, everybody. Cheers. Oh, let's find someone to raid. I forgot. If anyone's still around. Science and technology. Yeah, I totally forgot. Everyone probably left by now, but if anyone's still here. Cool. All right. Someone doing Laravel. Foo for the City, you're still here. Good to see it. We've got the author of Biscuits. Maybe we'll do. Let's do it. Yeah, let me give him a shout out real quick, actually, as well. If you didn't see the shout out before, he's a great streamer. He's a great person. Highly recommend checking him out. We are gonna raid CM Griffin G. Wow, we have a lot of viewers here, huh? Thank you so much all for coming. It really makes, I think, both of our days to have everyone hanging out in chat and talking to us, and yeah. Seriously. Oh. Jennifer says it makes her day too, and she also appreciates you all so much. Did I get all that, Jennifer? I think I got all that. Yeah. Thank you all so much from both of us. I'll see you soon. We'll see you next week. Let me just talk to Chris real quick.